Hello everyone. Today we are going to derive the equation for velocity of rocket. Here I have drawn the figure of rocket where I have shown the exhausted burning fumes getting out of the rocket in downward direction. So before proceeding, let us write some representations. Here I am writing m naught. Let m naught be the rest mass, or we can say initial mass of rocket. Which means it is the mass before the rocket takes off from Earth. Now let m be the instantaneous mass. Which means when the rocket takes off, the fuel in the rocket starts burning, which leads to decrease in the mass of the rocket. That's why we are taking the instantaneous mass m. Next, let small m be the mass of exiting exhausted burned hot gases. Which I have shown in the figure with orange shade. Burned hot gases per second. And the final term, let capital V be the velocity of rocket in vertical direction. V be the velocity of rocket in vertical direction. Now here we can write, in next step we can write the rate of change of mass of rocket with respect to time. Here I am writing rate of change of mass of rocket with respect to time. Since rocket is moving, the fuel in it starts burning out. That's why the mass changes. So here I can write small m is equals to minus dm upon dt, and I will give this as equation number 1. Here minus sign shows that the decreasing mass of the rocket. Here you can write in note format, note negative sign. Here negative sign shows the decreasing mass of rocket. Decreasing mass of rocket. So this was our first step. Now I am writing here step number 2. Now what we are going to write in step number 2. Here we are going to assume let the velocity of exiting exhausted gases relative to rocket is minus u. Here I am writing let the velocity of exiting exhausted gases relative to the rocket is minus small u. Here why I am writing the minus small u? Since our rocket is moving in upward direction, but the direction of exiting exhausted gas is in downward direction. Here I have shown with orange shade in this figure. Similarly, small m was the mass of these exhausted burned hot gases per second. So here I can write in the note format. Here minus sign indicates gases moving in opposite direction, moving in opposite direction of rocket. We have considered that rocket is moving in upward direction with velocity capital V, which we are going to derive in our next steps. So therefore, when we combine this, that is the velocity of rocket and the velocity of this exhausted burning gases. Our next step, I am writing the velocity of gas. Therefore, the velocity of gas exiting relative to initial frame will be equals to, it is nothing but the combination of these velocities, that is the velocity of rocket in upward direction and velocity of exhausted burned gases in downward direction. So after adding both, we can write minus u plus capital V. So this is the velocity of gas exiting relative to the initial frame. So this was our step number 2. Now in step number 3, we are going to do some calculations. This is step number 3. In step number 3, we are going to start with according to the principle of conservation of momentum. Here I am writing according to the principle of conservation of momentum. Now according to principle of conservation of momentum, here I can write mv, where m is the instantaneous mass which is changing and v is the velocity. That's why I am writing here d by dt, since it is changing with respect to time, which will be equals to, here I am writing mass small m. What is small m? Small m is the mass of exiting exhausted burned hot gases per second into the relative velocity. What was relative velocity? Minus u plus capital V. And here there is one term we are writing capital Mg, where capital Mg is downward pull of rocket due to the gravity. Capital M and here G. We can show that there is downward pull due to gravity. Here I can write capital Mg for just representation. Now here you can see in this equation I can write this term as minus, since the next term is moving downward direction. That is the mass where we have taken small m, that is mass of exiting exhausted burned gases, is moving in downward direction as opposite to the velocity of rocket where rocket is moving in upward direction. That's why here I am added the minus sign. So this is our equation. Here I can write where mg is downward pull of rocket due to gravity. So let me explain this equation once again. According to the law of conservation of momentum, here I have written capital M into capital V, where capital M is the instantaneous mass. Since it is changing, the mass is changing, that's why I have written here d by dt into mv, which will be equals to minus m, where m is the small m is the mass of exiting exhausted burn gases, and since this is in downward direction, here I have added the minus sign, also which will be multiplied by the velocity, that is the relative to initial frame. So here I have written it is multiplied by minus u plus v And here I have added the extra term minus mg, where mg is downward pull of rocket due to gravity. Now here I am going to do the derivation. Therefore, when we differentiate the first term, what we get here, I can take v common, dm by dt plus, now I can take capital M as common, dv by dt, which will be equals to, now see, in equation number 1, we have already find out the value of small m, which is the minus dm by dt. So I am substituting this value in above equation. So here I am writing minus, what was the value of m? It was minus dm by dt. Remaining term as it is minus u plus capital V minus mg. Here I can write from equation 1. From equation number 1. Now we are going to simplify the terms. Therefore, v dot dm by dt plus m dv by dt, which will be equals to, here minus into minus will be plus, so dm by dt minus u plus capital V minus mg. Therefore, v dm by dt plus m dv by dt. Now here I am going to multiply by this bracket, dm by dt into minus u plus v. So here I can write minus u dm by dt plus capital V dm by dt and minus mg as it is. Now here you can see there are two terms in the above equation, v dm by dt, and also the same term is on the RHS, that is right hand side, v dm by dt. So here I am doing the arrangement. So v dm by dt, I can transfer this term over here to the LHS. It will become minus v dm by dt, and write the remaining term as it is, m dv by dt is equals to minus u dm by dt minus mg. So here I can cancel out these two terms. Here I cancel out and write the remaining terms. Therefore, m dv by dt is equals to minus u dm by dt minus capital mg. Give this as equation number 2. Here I can write this term m dv by dt, which gives the net force or thrust acting on the rocket. So here I am writing the note. Here m dot dv by dt gives the net force or thrust acting on rocket. So you can write in the note format. Now from equation 2, what I can do here is that I can transfer this m, capital M, to the RHS. So in LHS it is in multiplication. So after going to RHS it will be in the division. So therefore dv by dt equals to minus u dm by dt upon capital M minus mg upon capital M. So here I can cancel out the capital M and capital M. So write the remaining terms. Therefore dv by dt equals to minus u by capital M dm by dt minus g. Now again I am going to transfer this term dt to the RHS. In LHS it is in division, so in going to the RHS it will be in multiplication. So therefore dV is equals to minus U by capital N dm by dt into dt minus g dot dt. Here again I can cancel out this term, dt gets cancelled out. So write the remaining term. Therefore dv is equals to minus u dm by capital N minus g dot dt. So this was our equation number 3. Give this as equation number 3. So equation number 3 we get dv is equals to minus u into dm upon capital M minus g dot dt. Now here we are going to find the velocity of the rocket, that is capital V. So in next step, that is in step number 4, what we are going to do? We are going to integrate the equation number 3. So this is step number 4. So in step number 4 I can write integrating equation 3, we get on integration we get integration dv is equals to, here minus u is not changing, what is changing is capital M, that is capital M was our instantaneous mass which is changing due to burnout of fuel in the rocket. So that's why I am writing here integration dm by capital M minus, here g is gravity, acceleration due to gravity, which will not be changing, which will be constant. So write the remaining term integration of dt. I can simplify this equation again. Integration dv is equals to minus u. Here I can write this term as 1 upon m into dm. Why I have written this? We will see in the further next steps. G integration dt. So give this equation number 4. Now we know one identity. We know the identity that we know that integration of 1 by m will be equals to log to the base e capital M. We know this identity, integration identity. So here I am writing using the identity in equation number 4. So after using the identity we get, after integration the term will dv will becomes capital V is equals to minus u. Here integration of 1 by m is log to the base e m. Here integration of dt is t, so g as it is, and integration of dt is t, and here I am writing the constant of integration. So give this as equation number 5. Now initially what was happened, that initially before the rocket takes off, we can consider at time t is equals to 0, that is before the rocket takes off. At that condition the mass which we considered rest mass will equals to the instantaneous mass, that is there is no change in the mass since the rocket hasn't taken off yet from the ground. So here I am writing now initially at t is equals to 0, which means the rocket hasn't taken off. At that condition we can consider capital M is equals to m naught and V is equals to V naught. So therefore equation number 5 becomes, equation 5 becomes V naught, V is equals to V naught. I have written here So I can replace v by v naught, that is the initial velocity, which means rocket is not moving. Here minus u log to the base e, m I have replaced with m naught, and since I am considering time t is equals to 0, so this term gt will become 0. So I can write here plus c. Now I can find the value of c, that is constant of integration, by interchanging the above equation. So therefore I can write c is equals to v naught plus u log to the base e m naught. So this will be our equation number 6. What I have done is I have written v naught as it is, and I have transferred this term minus u log to the base e m naught to the RHS. So it will become plus u log to the base e m naught. So here we have find the value of constant of integration. Now what we can do is we can substitute this equation number 6 in equation number 5, that is the constant of integration. So here I am writing substituting equation number 6 in equation number 5, that is the constant of integration I am substituting. So equation number 5 becomes v is equals to minus u log to the base e m minus gt. Here I am writing the value of capital C. What was the capital C? Which was plus v naught plus u log to the base e m naught. So now I am going to rearrange the terms and write this as v is equals to v naught plus u log to the base e m naught minus u log to the base e m, and the remaining term minus gt. Here I have done just some rearrangement, so we can simplify the equation. Therefore v is equals to v naught. Now see, in these terms u log e to the log e m naught minus u log e m, here u is common, so I can write it outside. So u log to the base e m naught minus log to the base e m and minus gt as it is. Now we know the identity log a minus log b. So here I am writing using the identity what was the identity? Log a minus log b, which was equals to log a upon b. So I'm going to use the identity in above equation. So here I'm writing using the identity in above equation. So therefore capital V is equals to v naught plus u. Now here I am writing the identity log a minus log b is equals to log a upon b. So it will becomes log to the base e m naught upon m and minus gt as it is. So this give this equation number 7. So this can be considered your final equation, that is velocity of the rocket. Now here I am considering one case. In case if t is small, that is time t is very small, which means the rocket just taken off from the ground, the term minus gt hardly makes any difference. Which means this is the condition where rocket is just taken off from the ground to go into the space. That is, I can write here, that is, there is hardly any appreciable hardly any appreciable reduction in value of V. Reduction in value of V. So if we neglect this term, that is, if we neglect the minus GT term, so our equation will become, here I can write one step further, thus neglecting the effect of gravitational pull of rocket. When we are considering this step when t is very small, that is, the rocket has just taken off from the ground. Rocket when t is very small. I am not considering t as 0. Here I am considering t is very small, approximately 0.7 second, 0.8 second, or 1 second, etc. So this gravitational pull will hardly make any sense. So it will not affect the velocity. So final equation. So here I can write, therefore equation 7 becomes, if we neglect this term, when t is very small. So final equation becomes V is equals to V naught plus U log to the base E m naught by m. And this is our final equation. So this is our final equation. In exam, if you write till here also, it will be okay. If you haven't considered the special case, you can still get the full marks for the equation. So both equation number 7 and equation number 8 can be considered as the velocity of rocket. Here equation number 8 is the special case of equation number 7, where we are considering the time t is very small. So equation number 8 is nothing but the special case of equation number 7. Both equation number 7 and equation number 8 represent the velocity of rocket. So that was it for today. Thank you for watching. Please subscribe for the more videos.